Okay, welcome to part two. So in part one, Monica had this code for Bloom's taxonomy for helping instructors, especially in higher education, think about learning objectives and applying Bloom's taxonomy to them. Basically, it says, hey, what verb is in your learning objective? And then it looks up that verb and where it is within, ooh, my computer's slow. Remember, watch this on 2.0 speed at least. And then says, okay, well, what level of Bloom's is that? And then based on what level of Bloom's it is, what would be the assessments that would make sense? What would be some question prompts that would make sense? You'll notice that those assessments and question prompts change when the level changes. Okay, so that was last time. And then we went through and cleaned it up some. And we're ready to try to do some matching. And what it does is right now, it requires the user to just pick the verb out of their learning objective. And then once they input just that word, just that verb, then it tries to find it here and gives them this information. What if we tried to create a way they could just drop the entire learning objective in, and then it would try to identify where that was in Bloom's taxonomy. Okay, so let's grab some learning objectives. Whoa. I got these from Menards, just kidding. I got these from Carnegie Mellon, a website at Carnegie Mellon, and a couple other websites where they were showing here's some good ones, here are some ones that aren't so good, here's what a learning objective might be. So you can see like state theorems. Well, state theorems, that's certainly not creative, right? So when we were looking at Bloom's before, I mean, maybe you didn't watch the first video. Let me bring it over. When we were looking at Bloom's taxonomy, we want to be at the top, create, because if you make your students or have your students create something, they probably have to understand it, apply what they understand, analyze something in order to design it. And then in that design, they're probably evaluating if their design's any good. At least hopefully they are. Okay, but if they're just stating something, then maybe all they have to do is remember it. Unless it's maybe like state the relationship between two subconcepts. Then maybe they have to understand it, but they could still memorize the definition, potentially. And so you'd be at the lower end of Bloom's taxonomy, which would be less advantageous because you don't have to, like you might never make it to design if all you're asking your students to do is remember stuff. And then they'll be less likely to use that information or use that understanding later on because they don't know it very well. The higher up you go, usually it means you know it a little better. Okay, where were we? Yes, so here are some learning objectives. Like we said, state theorems, not so great, right? Apply theorems to solve problems, that's a little better. Obtain a working knowledge of, well, maybe that's understand, right? Decide when a given theorem applies. Okay, there you're analyzing at least, right? Maybe you're evaluating, so you're up at maybe level 5 with evaluate. So we've got these different levels. I just threw them into a list. And then what we're going to do is we're going to try to get matches. And we're using the FuzzyWuzzy package for this. So let's create a function called getMatches. And so the first thing we want to do is we want to create an empty list. And then we're going to iterate through the list that was passed. So we get a list. We're going to create this new list, and now we're going to look for every object in this list that was passed. Oh boy. Okay, so this is learning objects list, right? But we don't want that inside of this function. This should be list. Okay, so define get matches list, match list for object in list, which is learning objects list, but it shouldn't directly be called that. Okay. Then verb options, this is going to be another list of, and then this is the FuzzyWuzzy where it's going to look at the object for object and list. So each one of these is an object. So this is a prove theorems is an object. And so it's going to take, and this long one, students will analyze American foreign policy from 18th century diplomatic relations, blah, blah, blah. So it's going to take that whole thing as the text, and it's going to try to match it to a whole bunch of things. And in our case, our whole bunch of things is the verb. The verb column. So it's going to be support or select, et cetera, et cetera. Analyze, 87, analyze. And you'll notice here, so this one should select that one as the most likely. Limit 10 means it's going to bring back 10 that it's going to say these are the most likely matches. So we think it's going to be the first one, but maybe we'll bring back a couple. Maybe we'll bring back 10 just to see what happens. Okay, so let's come down here and go with this. So we've got get matches, and then we've got this learning objects list. Let's run this once and see what we get. We're going to change it a little bit, but let's just see what we get if we run it this far. Okay, so if we look over here on the side, we've got this straight objects. We can explore it right here. Okay, so the first one, analyze, and okay, that's just showing us one. We're gonna need to add this in there. Okay, so otherwise it was just overwriting verb options every time, and then we probably just got the last one, which was analyze. Study, design. Analyze was 60% chance that it was analyze, and that was at number 104. So if we go to 104, I was wrong about that. That must mean something else. It's a 60% chance that analyze is the winner. Okay, so now if we run this, we should get a list, this match list, but then we want to actually pass it match list, right? Let's run it again. There we go. Now we've got a bunch of them. Okay, so you'll notice it's got analyze is the first one at 60%. Study is 48%. You know what? This 60 might have been right once it added in all those extra ones, right? Or sorry, 104 might be right because it's adding in those extra rows. We wouldn't find it at directly 104. It'd be somewhere a little farther along. Oh, you wouldn't think it'd be this far along. Anywho, let's stay over here. And so this might be useful. What else could we do? Well, I thought about going to bed for a second, but why do that? Why not just keep doing this? Okay, so we've got the straight ones, and this is just matching the learning objective with the verb. We might want to expand it though, because sometimes the verbs that are in these learning objectives might not match directly, but a verb that's very similar might be a match. So we might want to add to this on that side. On the other hand, excuse me, sometimes this exact verb, we could go the other way and we could look for sin sets within WordNet for that verb over here, and then we could look for that too. So I think it's, you don't have to do both. You could do one or the other. I think it might be easier to add extra verbs that mean almost the same thing on this side because these are the strings than doing it over here. Might be just as easy, but I'm going to claim that doing it over here is just fine. Okay, so we've got this straight observation based on FuzzyWuzzy. Now we're going to try to do a little more with it. So we're going to create a new function. And so we'll call it verb focus. And then it takes a list and tags strings in each and returns a list that includes sin sets of the verbs. Okay, you don't know what sin set is maybe, but you will soon. Okay, so first thing, so this takes this list. So it takes this learning objectives list. So, and then we're gonna, just like before, we're gonna make a new list over time. So what we're gonna do, we're gonna have 4 string in list. So each one of these is a string and it's inside this list. So for each one of these, we're going to do something. First thing we're going to do is we're just going to say S equals string. Okay. And I didn't have it like this originally, and then it wasn't working, and I did this, and then it worked. So I'm going to stick with it. Okay, so first we're going to tokenize the string. So we're using the NLTK toolkit, natural language processing toolkit. And so we're going to using NLTK.wordTokenize. And we're going to tokenize the string. It basically means it's going to separate the string into words. And each word is going to be an element in a list. Okay, and this just does it for us. We could use split and do it ourselves, but this is cleaner. Okay, next thing, they've already thought about punctuation and how to handle that. Next thing we're going to do is we're going to find the part of speech for each item in this tokenized string. So what's the part of speech for obtain? What's the part of speech for A? Working knowledge of X. You get the idea? So the part of speech variable is going to hold this tokenized string with the part of speech tuples. Okay. And then we've got the next part. So what if we just ran this so you could get a look at what it looks like? So let's do return tokenized string, part of speech. Okay. Now this is just going to get it for the first one, and it's going to return it. And so it's not going to work exactly how we wanted it to work, but that's okay for now. And let's just go print augmented. Okay, so now augmented should be this tokenized string in the part of speech for the first one. Run out of water. Okay, so you notice that the tokenized string is right here, state, comma, theorems. And then the part of speech, it's this, you've got these tuples, which are two things. The first one is state, which is the word, and the second one is NN, which is a type of a noun. And then theorems is NNS. So state theorems, so you could have theorems from a state, like the state of Kentucky has a theorem, or more like a nation, like a country's theorems. This is not right. This should be a verb, state theorems. So this one might get missed with ours, but other ones might make it. Anywho, you get the idea as to what it's doing. Let's get rid of this for now, because that's not exactly what we want to do. Okay, where were we? Part of speech. But then we want to cycle through the part of speech tag for each string. And we're looking for it now. Down here, you noticed we were going to miss out on this one because it's a noun. But in most cases, it should parse it and find the verbs for us. So let's come here for pair in part of speech. So remember, part of speech, you've got this list. And so for each pair, this is one pair, this is one pair. For pair in part of speech, let's look through it and see if one of them is a verb. And we've got to tell it exactly which one to look at, because you'll notice here, it's not the first one. This is the 0, and this is the 1, okay? So we want the 1, so that's why there's a 1 here. Now, what's this 0 doing? Once you get to a string, when you give it a number, it's going off of the character position. So notice how this is NN. For the verbs, it's the same way. It's like V something else. There's like 3 or 4 different ones, but they start with V. So all we care about is, does it start with V? So if the pair, the first one, which is the second one, because it starts at 0, and then the 0th position is a V, then do some stuff. If not, ignore it. So then what it's going to do is we're going to create a new variable called synsets. And then we're going to use NLTK corpus WordNet synsets. And we're going to look for synsets that have the part of speech verb that match in position 0. So pretend this was a verb here for state. Then it would say, hey, get me any word that's also a verb that hangs out, that's very similar in meaning to state. State, declare. Well, that's 2 that I can think of 1 that goes with state. So that's what it's doing here. It's saying, give me a list of any other verb that's extremely similar, almost synonymous, basically synonymous with the verb. So pretend this was a V here, then with state. So it's going to give us a list. Okay, then, and I know this is getting, very nested, but then for every word that it finds that's similar within this list of synsets, so for synset and synsets, what are we going to do? Well, sometimes two different words that are both verbs will like have slightly different meanings, but they'll be the exact same word. So in that case, we don't want that because we already have that word. And if we add the same word to our string, it's not going to help us match better. So if the pair 0 word does not equal the synset name, so this name, and then we have to do this split thing on this dot because what it actually gives us is like, let's just print let's do it up there. Just print synsets. Of course. There. Okay. Let's get rid of that. Get rid of that. Okay. So you'll notice that when it finds one that's similar, so solve, resolve, clear, obtain, receive, prevail, these linguists in the 70s got together, got a grant to get together and create this whole ontology of language. And they created this system, and eventually this system was, made accessible to Python, et cetera, et cetera. And WordNet, something inside that toolkit. So when we get solve.v.01, I mean, we don't need that. We don't want that whole thing, right? We're never going to match solve.v.01 to anything, but we are going to match solve. So that's why here we're trying to match to see if the pair 0, which again is probably in this one. Nope. In this one, this pair 0, pretend state was a verb, seen as a verb. If state matches with the synset name, but only give us the first one when you're splitting on this. So it creates a list from here and it splits on the periods. So the 0th element, the first one, and forget about that stuff. So that's what this part is doing here. So if they're not the same, I guess we could print it so we could see what it is. What's the new one coming in? And then if the synset name split, this thing again, is not in the string list, because here we've got the string list for each string. So if that name, so if it's not related up above to the pair, it could still be in the list, because we could have two synsets that aren't the same as the one in the pair, but are the same as each other. So we want to make sure it's not in that string list already. And if it's not, let's put it in there. Okay, now we want to go not on the 4. We want to go, I think, here. Yep, right in from the 4. So it does all this stuff over and over and over again for each of these different ones. And then it gets to this level and goes, hey, is there anything in the string list? There's not. Well, forget it. Well, there's something that it does then. But if it is, if there's something in there, then st, this new string equals, so then basically join everything in the list with one space. So put one space between everything in the list and turn it back into a string. Or turn it into a string. And then we can do a few things so that we can kind of report to ourselves. So then print, this is the string. So it's printing the original string from up here. And then it's printing, this is the list. And it's printing this joined list. And then it's bring them together. SS equals the sentence plus a space plus the joined list as a string. And then it's printing, this is the combined string list, SS. Okay. And then what do we want to do finally? Finally, we want to append this SS to the new verby list. New verby list, we finally get there. Okay. Then what if it didn't? If there's nothing in it, then else just print. Again, we take these print statements out, but we could just have them in there to say, hey, this is what's happening. This string did not grow. And then we've got this verby list. We just append the original sentence string. So we just would append, maybe we stopped printing them. We just append this as itself. So we take this state theorems, it would run through this, it wouldn't hit on any of these, but we still want to keep it. So then we just throw it back into this new list so that we've got it and it's in the same position in that new list. All right. Then we finally want to return what do we want to return? Well, I want to return the new verby list because that's the whole thing we built, right? So now when we run this, augmented will be, excuse me, this whole verb focus. This new verby list will be augmented, and it should have more than the list had before. So we've got the straight object. So we've got the learning objectives list. I got the, okay. So if I come down here and we do print, this is the original list. Okay. And then we get this, and then we go here and we do augmented list. Okay, this might give us an error, but let's see. Come on. Okay, this string did not grow state theorems. That's not surprising. Okay. So you'll notice here, it added, so understand, it added formation and sympathize. Oh, identity formation, it added sympathize. Sympathize, understand, okay. This is the list. Think, regard, view, switch, shift, transfer, stir, careen, lurch. Oh boy, and then it's the combine. Okay, so you can see how it did there. Then, finally, we could take our augmented list and run it through get matches that we made earlier and see if it does any better. So let's do that. Okay, we made it to the end. And so here we've got, this is the plus synsets. And then the other one is the straight objects. So we've got straight objects and plus synsets. Excuse me. Okay, so I wouldn't expect state to change because it didn't get any sort of extra help. Analyze was at 60 here, format 60, acquire 60, deprecate 60, and let's go look here. Analyze 60, format 60, indicate is at 53, and was it deprecate? Was it 60? Okay, so this is showing or attempting to show how you might start with a spreadsheet-based data, combine it, turn it into a data frame, and then how you might go from that data frame and add things like WordNet from NLTK, tokenization, and part-of-speech tagging in order to increase search accuracy. I'm not saying we actually increase search accuracy, but we're in a position where we could try lots of different things out in the NLTK toolkit to bring that about. Okay, I'll put some of this code in the information in the comment section of this video.